But anyways, it's again a fresh and recap of that. Okay, so it will be in the sequence. So first we'll learn what is monolithic application and what is microservices, and followed by virtualization, and we also see what is the drawback of each and everything, and what is the reason of learning containerization and what is its advantage. So this is the whole story of Docker. Then only if I start directly a Docker, it will not be useful for you. So I'll start with the history, and then it will be easy. So today, truthfully, it will be theoretical. Okay. So yeah, what is monolithic? Sorry. So what is monolithic? Monolithic is nothing but if you see, so in an architecture nothing but in a software industry. Okay. So let's take, if you have one server, I'll try to explain this. Okay. So first we'll go to the definition. For all services, if we use one server and one database, we can call as a monolithic. Okay. Example, e-commerce SaaS application, or take Paytm app, movie tickets, booking, etc. These are called services. Okay. In an architecture for all services, just highlight this word, all services. Okay. If you use one server, again, just I'll highlight this one server. Okay. And one database will call as a monolithic. Okay. So I'll try to explain this over the picture. Okay. Let's take it as a monolithic approach. Okay. So if we have one server, okay, and one database, okay, so this is monolithic architect architecture. Okay. So this is something called server, this is something called database. So in one server, if we are hosting multiple services and the example, if you take Paytm, okay, Paytm, or we have many things. Paytm. So in Paytm, if you see, we have recharge, and what else we have? Like we have bookings, movie tickets. Okay, bookings, uh, movie tickets. I mean bookings, nothing but it can be train tickets, movie bookings, and flight bookings. Many things. So these are the, I mean, I'm just saying example, but nowadays everything is in microservice architecture only. I mean, okay, just assume we have one server and we have one application called Paytm. So Paytm, if you open, recharge is one of the service. Okay, if you click on recharge, it will open one UI, right? It will ask phone number and everything. It is one of the service. Similarly, train booking. If you click on train booking, so it will ask from starting station like something Secunderabad, and will be giving destination as Vizag, something like that. So, and it will ask number of like passengers, adults, something, and something it will ask, right? So it is one of the service. Movie bookings, it's also one of the service. Flight booking, it's one of the service. Okay. Next, gas booking, maybe. Then we have many things. So all these are called services of an application. Okay, services of an application. Paytm is the application which is running on this server. Okay, so Paytm is the application which is running on this server. Okay, so this is server, right? So Paytm is only one application running on this server, and it contains all these services. Okay, the recharge is the one of service, train booking is the one of service, movie booking, flight booking, gas booking, electricity payments. So whatever, when you open your Paytm application, whatever you see on the dashboard, so those are called as services. So services altogether called as an application. Okay. Services altogether called an application. Paytm is an application. When you open that, whatever you see are called as a services. So when you club all services together, it's called an application. That's clear, right? Now, so database. So why database? So we'll see more clear later. We'll also create database in the future classes. So what is database? Database is something like which will store the things. Okay, as of now, just to store the transaction. So when you open the Paytm, right? So when you click on transactions or their history something, there you'll be seeing what and all the transaction you did for certain duration. Okay, so how these are storing, right? So there should be some storage, that is called a database. So database is nothing but it will store the transactions. Okay, when you book the ticket, it will store the information, and when you try to uh, go for the history, it will retrieve the information. So okay, how it is done is, when you book any, let's like when you book when do you do recharge, right? So it will, when it got successful, it stores the transaction details in database. Okay, so and at some point of time after some days, so you want to check the recharge history, then you'll go open the Paytm and you'll go for transactions. Then automatically this service, that you will click on transactions, right? There is something called transactions or history. Okay, so you'll click on this button. Okay, so when you click on this button, what it happens in the back end is, right? So it will ask the database to provide the information of maybe for last 30 days or 60 days. Depends upon the filter. Okay, so what database will do, it will gives the information to the transaction service. So this is something called as retrieving the information. Okay, so something is called as retrieving the information. Okay, so retrieving the info. Okay, and what this database do, database basically, as of now, you just understand, it will stores the information, or it will stores the some data. Okay, so whatever the Paytm do, okay, whatever the Paytm activities it will do, right? So recharge, or doing recharge, or book tickets or something, whatever, movie bookings, anything, sending money. So all the transactions are need to be stored in some place. So that is called as a database. So whenever required, the database also will, it will not only stores, it also provides information. Okay, if you want to check, it will retrieve we can retrieve the information from the database. Okay, so database, you are clear. Okay, right? So now, so this is called monolithic architecture. Okay, so this is called monolithic architecture. Okay, so where one application, all the service of the application running in one server. Okay, so these are the services, right? So these services are running in only one server. So that is the highlight point. Okay, one server, just keep it as one server. And all the services database, it's a common, and it is running on an other server, only one server and one database. So this architecture is called monolithic architecture. Okay, so what happens, I mean, you got the definition, I hope you got the definition. I'll read once again the definition. In an architecture, for all services we use one server and one database, we call as a monolithic architecture. Okay, so that is clearly explained here. All the services, okay, all together or in present in one server and one database. So this architecture is called monolithic. So this is very important, monolithic architecture. So to understand what is monolithic and what is microservices, very important. Okay, yeah. So example, we have taken a Paytm app. Okay, Paytm app, I like movie tickets, bookings, etc. Already I have explained, that is very clear. So if all the services are included in one server, then it will be called as a monolithic architecture. That is clearly clear. Okay. It's also called as tight coupling. Okay, because the services are highly dependent on each other. Because if you see here, this architecture, what happens, all the services are bundled each other. Actually, they're tightly coupled. Okay, if you take one box and if you keep all the things in one box, what it will be, or what it will be happen, so those the things are will be tightly, I mean, will be present in that box. So similarly, all the services are tightly coupled in the server. Okay, so that is what monolithic. So I'll be very much slow in this today's class, because The concept is important, so that's why I'm going to stress it. Okay. And the services which you see, right? So those are each, I mean, same server, right? So they are depend on each other. Okay. Because why? So you may get question, why these are depend on each other? Because see, if you see the recharge, okay, so recharge is using same server, and train booking is also using same, these services are using same server. So the hardware components of the server like CPU, memory will be the same. So CPU, okay, memory, okay, so it's common for all the services. So that's why, so all the services are depend on each other. Okay. Because they are tightly coupled. Okay. So this is about monolithic. So let's see what are the drawbacks for it. Okay. So the drawback is, if one service is down, means we have to shut down entire application to solve that service. So user is facing problems because of tightly coupled. Yeah, that's obviously. So you see here, let's say like recharge is not working, recharge service is not working. So what you will do? Okay. So because all the services are sitting in one place or one server, so in order to troubleshoot or in order to fix that service recharge, okay, so recharge is not working. Okay. So recharge, if it is not working, I want to fix it, right? So I want to apply a fix, means I need to do something, maybe restarting or doing service restart. I want to do something. So that we seems, I mean, we know like all these are tightly coupled. If I disturb one thing, all other services also will be disturbed, because they are each other depend on each other. Okay. So that's why what I'll do, I'll bring down the Paytm application down. So I will stop the Paytm application. Okay. So I will stop the Paytm application. Okay. So I'll stop the Paytm whole application itself, and I will try to fix the error of this recharge service. Okay. So what happens? So all the services, if I stop the application, right? So all the services also will gets affected. Okay. So this is something like a drawback. Why? Because if there is issue with the recharge, okay, ideally, so we need to stop that recharge only. Okay. So but if there is some issue with one service, the whole application, why it should be stopped? That is the question. Okay, application came. If you have issue, సో ఆ అప్లికేషన్లో ఒక్క సర్వీస్ మాత్రమే ఇష్యూ ఉంది అనుకోండి, మనం రీఛార్జ్ నొక్కితే రీఛార్జ్ రావట్లేదు అన్నప్పుడు, అది మనం బ్యాక్ ఎండ్లో రిజాల్వ్ చేయాలి. అది ఒక్కటి మాత్రమే స్టాప్ చేసి రిజాల్వ్ చేయాలి. టోటల్ అప్లికేషన్ పేటిఎంని ఆఫ్ చేస్తే దెర్ విల్ బి నో ఇష్యూస్, రైట్? సో ఎండ్ యూజర్ విల్ ఫేస్ ద ప్రాబ్లమ్స్. So that is not the ideal solution. So that's why it's a drawback for this one application. Again, if sir, I'm just going to the definition again. If one service is down, means we have to shut down entire application to solve that service. So user is facing problems because of tightly coupled. So this is not encourageable. Monolithic application architecture is not encourageable for an application. So why we are learning this architecture is because when we deploy an application on server, we need to have one architecture, either monolithic or microservice or containerization. So what we are going to do the architecture, so that's why we are learning here. So this is monolithic is the first architecture initially, when software industry has begun. So they have used this architecture, which has drawback. Then later they went for microservice architecture. Okay. So microservice architecture is the one which is used widely. Okay. Okay. So this architecture which is used widely. Okay. So what is this architecture? Just go through it. If every service has its own individual servers, then it is called as the microservices. Just learn it. If every service has its own individual servers, and then it is called as a microservice. Highlight the points. Own individual servers. Okay. Every service, each and every service should have its own individual servers. So let me explain this same. Okay, let me save this. Monolithic. Okay. Okay. Now let's same example. I'll show in monolithic. So every service. Okay. First, let me. Okay. So this is what I'm going to do. It's a microservice architecture. Okay. So it's a microservice architecture. So in this microservice architecture, how the things are going to be is right. So every service. Okay. So every service we are going to have a server. Okay. Okay. Something like this. Okay. So these are okay. These are servers. Okay. S1, S2, S3, S4. Okay. So S5, S6, S7. Just I'm naming the servers. Okay. S8, S10. So we have 10 servers. Okay. These 10 servers we can use for hosting the services. Okay. So let's say like, so we have a service here is recharge. Okay. And here maybe you can say train bookings. Okay. Flight booking, gas booking, LPG gas booking. Okay. Fast tag recharge when I talking about Paytm. Okay. Then electricity recharge. Maybe spelling bad. Okay. Then what else we can see? Transactions, transactions. So and what else we can see? So what else? Uh, Send money. Okay. QR scan. Okay. And what else? Wallet. Okay. So so what you see here is, so what we are doing, so we are maintaining each and every service in individual server. Okay, that is the takeaway. So if you say take, this is Paytm, the Paytm application. Okay, Paytm. Okay, if you take Paytm application. Okay, right. So I'm just placing this service in one server, and train booking in this is services. Okay. So all the services are I'm placing in each and individual server, such that what will happen is, if anything is down, let's say like electricity recharge is not working. Okay. What I'll do, okay, there is issue with this service. So I'll restart the server or service. I'll troubleshoot it. If I stop this, all these things together, these things will not be affected, right? Because this is in separate server. This is different server. If this server goes down also, what happens? This recharge will not work. Electricity recharge will not work. But it will not affect all these things. So these are called loosely coupled things. Okay, loosely coupled services architecture is called microservice architecture. Loosely coupled because we are segregated, right? So the services are running on different. Each service is running on different server. So if any issue with the server or if any issue with the service, that service only will be affected, and no I mean, nothing will harm to the other services. The application will run without any issues. If anything with that services, only that service will not affect. If let's say like transactions, okay, transactions. So when you click on the transaction, if you open the Paytm application and if you click on Paytm app in your phone and if you click on transaction, at some time if you see that it is not working, okay, then that's okay. I mean, you can use recharge option, you can use send money, and the QR score, wallet, everything will works. But at a point, maybe transaction has issues. Then what the team will do? Just they'll troubleshoot this transaction service. Maybe the issue with the server or issue with the service. They will try to restart the service. Okay, and they will try to restart the server. Maybe server go down. So there are the things. So what ultimately we need to understand is, so here the services are independent on each other, independent, ఒక్కదానికి ఒకటి సంబంధం లేకుండా డిఫరెంట్ అంటే ఒక్కదానికి అంటే డిపెండెన్సీ లేకుండా ఉంటాయి. సో దర్ ఈస్ నో dependency between each and other. So whereas when you talk about monolithic, so what happened? So those all the services are placed in one server and they are tightly coupled. If anything happens to one service, it automatically the application we need to stop and fix it. So here that is not the case. Okay, I hope it's very clear. Okay, now, yeah, so it's a loose coupling. Yeah, so then we'll go for drawback. So drawback, so we talked about monolithic and it has some drawback. So drawback is like if all together in one server, that is causing the drawback. And so microservice also has drawback. It is too cost because we have to maintain so many servers and database, so maintenance is high. Okay, so maintenance, the per capita or the money which you are spending is very high. So because why we are saying is this because so we need to have these many servers. So maintaining the servers always, but technically we don't have any issue. But maintaining these things, the per capita or the expenditure, capital expenditure, so that will be increased because of having this 10 servers one for one application will be a huge amount invested. So the amount is also in a consideration when we are planning of architecture of anything. Okay, so money planning, like financial planning for everything, even for in our general life is important as well as for any application. So we need if you want to take any insurance or anything financial planning, so we will be planning with less cost and high yield. Okay, so here also if you invest on this money, right, so it will not be just 1 minute guys. Yeah, sorry guys. Okay. So where we are? Yeah, so we are discussing about microservices, right? So microservices we are drawbacks. So it's two costs because we have to maintain. Okay, I'm unmuted. So we have to maintain, sorry, things like maintain many servers such that like it will be more expensive. So that's the reason it's a drawback. But technically, when we talk about, it's a good. Okay, so if you see this, when we compare to microservice to monolithic, microservice is good to use, right? Because if one service is not working, so we work on it without shutdown in the application. That's the reason microservice is good and preferable. So someone like who is not bothered about the cost or the expenditure, so he can directly go for the microservices because there will be no dependency, there is no dependency between the services which are in. So that's the reason. So monolithic is very good to use when compared to the monolithic. So yeah, just leave the here, we'll go for virtualization. Later will come. So as I said, monolithic is done, that's very clear. And microservice done. Then we'll talk about virtualization. So what is virtualization? Okay, so virtualization is something is like okay, so while creating, if you just see, don't go with all these assumptions. Okay. So while creating the application, we need to install the dependencies to run the code, right? What is dependency? Okay. So let's say like if you are running a Java code, okay. So if you are running a Java code, okay. So what would be the dependency? Will be the Java need to be installed on the server, Java version. Okay. Java need to be installed, right? So Java need to be installed. That will comes under dependency, and the code will be the whoever developing the code. The code can will be clone it and will be deploying that. Will be building a jar application or war application and will be deploying in that server. So any application we deploy, so there it requires a dependency. Okay, any application we deploy, or if you want to deploy, so it must contain dependencies. Okay, dependencies plus code. So without dependency there is no application will be running on the server, right? Because just like if you have the code and if you deploy on a server, there it's a meaningless and it's not a useful thing. The code will not be running, because if it is a Java based code or Python based code, the dependence should be, the prerequisite should be Java. Suppose Java, we need to install Java, and if it is a Python based code, we need to install Python as a dependency. Okay, so then only what happens, the code will be running on this Python language. So that should be a dependency for every application. If you say Paytm or any application, IRCTC or any application, so whatever the language we are developing that code, that to run that code, we need to have the prerequisite that is called a dependencies. Okay, so this is clear. Okay, so this is one scenario. Let's like I installed Java, React.js, and MongoDB to, okay, to run the code. After some time, I need another versions of Java, React, and MongoDB for my application to run the code. It's really hectic situation to maintain multiple versions of same tool in our system. Okay, so this is actually, if you see these two lines, right? So these two lines is something like a scenario. So where just you need to assume to understand the next concept like virtualization as a Docker and a Docker. So to understand these two things, so you need to assume. Okay, so I have three applications. Okay, one is Java and React.js and MongoDB. So what I'll tell is, so we have Java, fine, React.js, fine, and MongoDB. So MongoDB is nothing but, I'll tell you, sorry, G for Mongo. Okay. So this is backend application, and this is React.js is front end application. Okay, let me. Why we are installing all these three? So these are depend on each other. This is backend. I'll tell you what is backend, what is front end. This is front end, and this is database. This is already, like it will stores the things. Okay, this is okay. So and this is database. So what is front end? So if you see any UI, so if you click here, so let's say whatever the maybe SBI or online banking or something, whatever this you see. Okay, so when you click here, it will open something called SBI banking page. Okay, sorry, yeah, it's coming, right? So you are seeing all these stuffs: SBI logo, SBI symbol, SBI name, SBI online, all the services. Okay, so these are services is one of the service, FAQ is one of the service, corporate. So all these are called services. So block ATM is one of the service. Okay, so everything you need to call it as a service. Okay, sometimes maybe FAQs doesn't work means SBI online banking is not working. Okay, so if it is an issue with FAQ service only, so they will rectify and they will fix. Okay, so each service will be independent in nowadays everything. Okay, so whatever you see, this thing is developed in React.js front end. Okay, so React.js is nothing but JavaScript. So it's like a UI, user interface. When you click it, you are whatever you're seeing, right? So this is something developed in React.js. Okay, so when you click on something, login, right? If you click on login, so when you click it, it will talk to the backend. Okay, so it will talk to the backend. So when you click on something, it will talk to the backend. Okay, talk, and when you give the username and password, what it will do? Okay, it will verify the things whether the user is there in or not there in the data. In the database will suppose if you have username and password, it verifies, okay, this is the right person. So it will authenticate. Okay, so it will authenticate the person. Okay, this person is already with us. So okay, whatever the username he entered is matching with the password whatever he entered, and those two things are in our database. So you can, okay, he can successfully log into the server. So that verification will be that those details will be retrieved from the database and passed to the backend. And when these two things are successful, so we'll be moving next step, we'll moving to the next page in the React.js. So all these things are essential for an application to fulfill an application deployment. Okay, so that is the case. We'll go back. Okay, so okay, what the scenario is, the scenario what he's saying is, so he has installed all these three applications. Okay, and now with version some v1 version, he has installed all these things. Now on the same servers, you need to install version v2. Okay, maybe he installed Java 8. So React.js some version, maybe I'm not sure about the versions. Maybe one React.js MongoDB like two, version 1, 1.1 something. Okay, so he has installed all these versions, and now in the same server he is planning to install in the same servers. He's planning to install Java 11. Okay, React.js version something to some different version. Okay, I'm not exactly sure about React.js versions. Okay, on the same server he want to install different versions. That will not be possible on a single server. Okay, so that will be not possible if already have Java 8 is there, and if you want to install 11, so that will be different. And for React.js already some version is there. If you want to install that, he can just upgrade it, but he cannot maintain two versions at a time. Okay, so what I'm saying is, if you want to upgrade from 8 to 11, he can do it. React.js 11 to, I mean 1 to 2, he can do it, upgrade. Okay, but he cannot maintain two versions at a time. Okay, so that is the, I mean, drawback, or like it will to maintain multiple versions, it will be hectic and it will be complicated when we talk about monolithic and microservice. Okay, so to overcome that, we are going to use a concept called virtualization. Okay, so what is virtualization? Okay, let's see now. Virtualization, like it is used to create a virtual machines inside one machine, and virtual machines we can host guest OS in the machines. By using the guest OS, we can run multiple applications on same machine. Okay, let's leave it. Okay, so we'll try to understand. Okay, so this is the diagram of virtualization, architectural diagram. So whatever I am saying in the paint for microservice, similarly the same structure already there in this document. So what is virtualization? So basically it is one server, one, let's say like one EC2 server. Okay, one EC2 server or one physical server. Okay, one physical server. On the physical server we'll be having a hardware, any server, right, will be having hardware and OS. Maybe we are taking, let's say like example, Linux. Okay, so we'll be having server and Linux. So these things will be having when we create a server. These are fine. Okay, okay. So now, so in order to have a multiple versions on a same server, okay, in order to have a multiple versions of application on a same server, we need to have something called a virtualization concept. So that's where we are to bring the virtualization architecture on the server, we need to install the hypervisor. Okay, so hypervisor is something like it's related to the, it will what it will do, it will use the host OS. I mean, host is nothing but a Linux. When we create a server, right? So that is called as, whatever the OS comes with the server is called host OS. Okay, hardware, you know. Okay, so what this hypervisor do is, so let's say like OS contains like four cores of CPU. Okay, okay, and some 8 GB of RAM. Okay, so 8 GB of RAM. Okay, so what this virtualization do? So let's say like, okay, what I'll do is, maybe I'll say like three cores of, as of now. Let me erase this. I'll erase all these things. Okay. So what I'll do is, okay. So what I'll do is, we have, so host OS have 6 cores of CPU. Okay. Something. Okay. Maybe I'll say 12 GB of RAM. Okay, so this, so when you create a server, okay, the host OS contains 6 cores of CPU and 12 GB of RAM. Okay, so this is the hardware components or the RAM components and CPU components. Okay, now, sorry, now, so what this hypervisor will do, so hypervisor will use this all the configuration of the server, and based on the, this is called as VMs. This is VM1, I'll tell you. VM2. So this is VM3. So VM is nothing but virtual machine. Virtual machine. Okay. So this virtualization concept is the ultimate for virtualization machines. Okay. So what is virtualization machine? I'll tell you. So basically, any software company, they used to have, there is no cloud at the times when they started. So they'll be having server rooms, and they will be having one physical server. Okay, so they will be having one physical server. Okay, okay, this is one server, this is called physical server. PS is nothing but physical server. Okay, Okay. So this physical server, if they want to host multiple applications, okay, okay, on the same server, let's say like the same capacity, 6 core CPU, okay, 8 GB RAM. So he want to, for example, he want to host the all these three applications, okay, all these three applications on the server, okay. So, but these servers, okay, all these applications are hosted, but those applications are using only two core CPU and 2 GB of RAM. So rest 4 core and rest 6 GB are getting unused, okay, and it's causing like we are not using, right? So that is just useless, and it will not be a good practice or good architecture to use that. So in that case, what happens on a physical server, if you partition it into a VM, okay, let's create a three VMs, okay, virtual machines from the physical server. So to create, in order to create a VMs, what we'll do on the, so structure goes like this. So this is physical server PS. On the physical server, will need to install the hypervisor, okay. Okay, let me remove it. Okay, so on a physical server, so on a physical server, so this is physical server where it contains host and hardware. On top of it, we need to install hypervisor. Okay. What hypervisor will do is, hypervisor will use the components of RAM and CPU, and based on that, whatever we mention, it will. So let's say like we need to have three virtual VMs. So it will create three virtual VMs. VM1, similar way. What I'm here creating. I'm just creating here VM1, 2, and 3. So VM1 is nothing but just like a separate server. This is also separate server, but they are virtually, not a physically. So virtually and physical, there will be a difference, okay. So virtually, which means those are not exist physically. So we are just using hypervisor and we are just creating uh, servers, okay. Why? Because we can host multiple versions, okay. So we can host the multiple applications here, okay. So those are independent of each other, okay. So what, suppose if anything happens with these servers, we can stop VM and restart it. So similarly, we can stop this VM and restart it. So something, it's like the resource utilization is increased, right? Earlier we just hosted one set of applications. Okay, now we are hosting three set of applications. So the main physical one server is split into three based on the resource. Resource nothing but CPU and memory. So now full resource utilization is happening at the same time. At the same time, so we can maintain on the same server, we can maintain three versions. We can host Java 8 something versions. In the second VM, we can host 9 version, 10 version, 11 version. So we can have multiple versions. So that is the reason we are going for VMs, okay. So if you see this the pic here, see, hypervisor is there to spread the resource utilization. And on the VM, right, I said VM, right? So on the VM, we can install the base OS, can be anything. It can be a Linux or Red Hat or whatever, okay. And this guest OS, we can, once we create the VM, right, it's a bare VM, we need to install the OS. So OS can be created anything, like it can be a Linux, it can be a Red Hat, it can be a Ubuntu, it can be a Windows also. So we can install anything. So that is the advantage, okay. So and this, before deploying, this is a code, right? So we need to have the dependencies, like dependency is nothing but before running anything, we need to have the Java or something like prerequisites we need to have. So this is the VM architecture, okay. Don't get confused, I'll just again just go through it, and I'll share this document, try to understand, okay. Host OS means the Windows machine, okay, that's not a problem. So hypervisor is also known as a virtual machine monitor. It's a component of software. It is used to create the virtual machines. So hypervisor is the only thing. It will use the resource utilization. It will create the VMs, virtual machines. So that I have already taught you. So what is the drawback? It's an old method. Yeah, of course it's an old method. So if you use multiple operating systems, virtual machines, then the system performance is low. Yeah. So this is correct because we are using guest OS here and the main OS is here, right? Server OS on top of it, we are using separate OS on the VMs. So because of this OS dependencies, what happens? The performance will be very something low. Okay. To overcome this performance issues or to overcome this, we are going for containerization that is called Docker. Okay. So the whole story behind all these things. Now we are just entering to the Docker. So virtualization, we have multiple OS. Okay. So first, what we discussed, monolithic architecture and microservice architecture. So even though if we have these architectures also, and we need to separate, right? In virtualization also, we are having a drawback called due to many OS present, the system performance will be low, such that the application will respond very slow. Okay. Now we go for containerization. Okay. So containerization, what is containerization? Container is nothing but a Docker. Okay. So just try to understand if you have and will be seeing in hands-on. Don't worry. So it is used to pack the application along with dependencies to run the application. This process is called containerization. Okay. What this containerization do? So this containerization you will do it. It will package the things. Okay. It will package the code as well as the dependencies. Okay. So that's the reason we are going for the. If you see here, so application is nothing but dependencies plus code. So we are just packaging both into a one bundle. Okay, okay, one file maybe or one image. Okay, so there is no need of separate installing the dependencies and making ready and just cloning code. Both are bundled together. So what happens if you just give this package to some other, they will just run it. Okay, otherwise in all what happened in all this virtualization and all microservices, they need to set up the dependencies, then we'll download the code and we'll run it. Okay, sometimes what happens, dependencies, I have installed java 8. Okay, Java 8 and have cloned the code. I have run the application. It's working. And some other people will, we just mentioned Java. So they have downloaded 11 and they have installed 11 and they have downloaded the code and they have run the application, but it's not working. So dependencies sometimes will change. So that's the reason the ideal way of containerization, why the containerization come into it. So no one need to install their dependencies. It's coming with the code. Then only it will be easy for the user. Just they need to run the package cloud, which includes dependencies and Java. So that is the use of container. Okay, so you'll be understanding if you go down. So this is the diagram of the container. Okay, so we'll be having server, host OS will be there. Instead of hypervisor, right? We'll be having Docker engine. Okay, Docker engine nothing but it will take care of communicating between the Docker containers and the resource of the server. So here we'll be having application and bin. So there will be no guest OS. There will be no separate OS. If you see here, just compare both. So here we'll be having hypervisor. Instead of hypervisor, we are having DE Docker engine. Okay, and here there will be no guest OS. Remaining everything will be similar. Okay, so and if you see the application code and the libraries dependencies, right? So these are clubbed in a container. So I mean, so whoever going to use, we will just give it's like a image or container, they will just run it. So these the two things are in that core, that package. Okay, so no need to install individually and run this. Okay, these are part of the container. So if you see it, it's a runtime of the application. What is container? It's a runtime of the application which is created to the Docker image. Will come to know. A container is nothing but a virtual machine which does not have any OS. What is container is nothing but a virtual, same like VM, but it does not have OS. It's clear. Okay, so yeah, it's similar to the virtualization architecture. Instead of hypervisor, we are having Docker engine. I have already taught you. Through the Docker engine, we are creating the containers. Inside the container, we are having the application. Docker engine, the software that hosts the container. In one container, we can keep only one image. Okay. So, uh, yeah. So this is what we covered about monolithic microservices, virtualizations, and Docker. Okay. Containerization is something like we are having the okay, we are having the code and dependencies together, so that is clear, and which don't have the OS. Okay, I think this is enough for today. Okay, so we'll have this is the introduction only. So we'll see the like what is before the doc, what happens before the docker coming to the picture, and after docker what happened, and architecture of a docker, and the life cycle of docker. Okay, we'll be seeing in the next classes. Okay, so